Welcome to helpyourmath.com. In this problem, number 5 in the 206.5 final review, what we're going to do here is evaluate the value of a trigonometric function of the angle without a calculator. Now here we're given two problems. We have sine of negative 9 pi over 4 and cotangent of negative 150 degrees. Now both of these angles are negative, so it tells us one thing. We have to either find the coterminal angles or find the representative angles in the unit circle that these represent so that we could determine what the value of these angles are. Now my take on this is basically convert these to positive angles so we could see where we lie in the unit circle, and then we could use what we know about trigonometry to solve this problem, right? And so we're going to start with negative 9 pi over 4 and negative 150 and convert them to positive angles. So let's find the coterminals of these. To get the coterminal angles, what we want to do is either keep them in radian or angles in degrees. And here I'm just going to keep it in radians because it's not so bad to use radians. So here we have negative 9 pi over 4. And what we want to do to a radian angle of measure is add 2 pi until this becomes a positive radian measure. So we're going to add 2 pi, and this is 2 pi over 1. We get negative 9 pi over 4 plus, and if we multiply this by 4 on top and bottom, we're going to get 8 pi over 4, which makes a common denominator between the two fractions. Now the only problem we're going to have here is when we add these two, it's still going to be negative. So here when we add negative 9 pi plus 8 pi's, we have negative pi over 4. And now what we want to do is continue to add 2 pi until this becomes a positive angle. And we know 2 pi is 8 pi over 4. So we're going to, again, add 8 pi over 4. And this becomes 7 pi over 4. Now this is a very big angle. So we're going to convert this angle to an angle of measure because we can use our common angles in trigonometry based on our common angles of measure. So we're going to change this from radians to degrees, and to do that what we want to do is multiply because we know pi equals 180 degrees. We're going to change this to a fraction in which we're solving for the radian measure of an angle, and we're just dividing both sides by pi, and these go away and we have 1, and 1 equals 180 over pi. So we're going to multiply both sides of this side of the fraction by 180 over pi to convert it from radians to angles. So we have here 180 over pi. And here we see the pi's go away. And we have 7 over 4 times 180 degrees. Now 4 also divides 180 degrees. If you're using a calculator, this will be a lot easier because we're going to have 7 over 1 because this divides this. And 4 makes half of 180 is 90 degrees. Half of 90 degrees is 45 degrees. So a fourth of 180 degrees is 45 degrees. And if we multiply this out, we're going to get 5 times 7 is 35, carry the 3. 7 times 4 is 28, plus 3 is 315 degrees. And that's our first angle. So here we know that this is the sine of 315 degrees. We're going to come back to this in a second. What I still want to continue doing is find the coterminal angles of each angle. And since this is in an angular method in degrees, to find the coterminal of this one is a little easier than this one because you're using whole numbers. And our angle, again, is 150 degrees. And to find the coterminal, what we do is we add 360 degrees in this case because it's negative. If this were a positive angle greater than 360, we would subtract 360. The same goes for this. If this were 9 pi over 4, we would subtract 2 pi until we get an angle between 0 and 2 pi. So in this case, we're going to add 360 degrees to make this an angle between 0 and less than 360 degrees. So when we do 360 minus 150, we get 210 degrees. So this becomes the cotangent of 210 degrees. Now that's the first step in solving this, finding the coterminal angles and converting the angles to their positive components, the same representation of what we have in negative values. So I'm just going to wipe this down so we can continue because there's a couple of more components we want to work with. Now, when we're dealing with trigonometric functions and we have 4 quadrants, we want to determine where these angles lie. 315 degrees, as we know, the first quadrant is right here, second quadrant is right here, third quadrant right here, and the fourth quadrant is right here. The angles for the quadrants go as follows: 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And finally, when you're back to the uniform point, it's the same as 0, 360 degrees. And this is why we subtract or add 2 pi or 360 degrees to get an angle between 0 and less than 360 degrees. The first angle we have here is sine of 315 degrees. Now we know 315 degrees lies in the fourth quadrant. It's somewhere over here. And that makes a 45-degree angle between 360 and 315. So our reference angle here, the theta, becomes 45 degrees. Another way to solve this is to use the points of reference angles for these quadrants. When you're in quadrant 1, you just take the value of theta. When you're in quadrant 2, you take 180 degrees and subtract the angle theta. When you're in quadrant 3 here, you take the theta and subtract 180 degrees. And when you're in quadrant 4, and you could tell that based on where your angle lies, is taking 360 degrees and subtracting your angle. So for sine of 315 degrees, we know we land in this quadrant because we're in the fourth quadrant after we go all the way around, right? So this is 315 degrees, and this is 45. They both add up to 360. That tells us one thing: we're in the right place. The second component of this is to determine the sign of sine in the fourth quadrant. And we've all heard the acronym ASTC, where this is called All Students Take Calculus. In the first quadrant, all values are positive for any trigonometric function. For the second quadrant, only sine and cosecant, its inverse, are positive. In the third quadrant, only tangent and cotangent are positive. In the fourth quadrant, only cosine and its inverse, cosecant, secant actually, not cosecant, secant are positive. So we're in quadrant 4 for sine of 315. Our reference angle we have to calculate using this. And we also know that only cosine and secant are positive in the fourth quadrant. Since our angle lands us in the fourth quadrant, we know sine becomes negative. And the reference angle for this value becomes the sine of 360 minus our angle. And this gives us a negative sine of 45 degrees, right? And finally, we have to use the common values table to figure out what sine of 45 degrees is. We already know the solution is negative. And sine of 45 degrees is always radical 2 over 2, based on what we know about common angles. And that's our solution for the sine function. To go to cotangent, which we could wipe off most of this stuff, which we elaborated from the first problem. Let's go to problem B now. And we need all of this still. So 210 lies in which quadrant? Well, we know that this is 180 and this is 270. So 210 is 1/3 of the 90 degrees that are in here. So 210 degrees lies here. Here's our reference angle. Again, the reference angle is always the angle between the line and the x-axis. And here we have this. And so we want to find we already know which quadrant we're in. We want to find our sine of cotangent. In the third quadrant, cotangent is actually positive. So we could just say this is going to be positive. We take the cotangent. We solve the reference angle, which is going to be the angle minus 180 degrees, and that's 210 degrees, minus 180 degrees. And also, just for a note, if you're doing this with a calculator, this works with a calculator. Sine of 45 degrees, you set your calculator to 45 degrees, this solves it. The problem with cotangent is, cotangent is not on your calculator, but we do know this is positive, and we have the cotangent of 30 degrees. And to solve the cotangent of 30 degrees, what we want to do is use the invert function. And cotangent of the angle is equivalent to 1 over tangent of that same angle. So what we're going to do here is we're going to use 1 over tangent of 30 degrees. So if you're plugging this into your calculator, you're using the tangent of 30 to solve the cotangent of 30. And you're putting 1 divided by the tangent of 30 to solve that. And so the tangent of 30 degrees, again, sine over cosine, right? So sine of 30 is 1/2, and cotangent of this is going to be 1 over radical 3. So we have 1 over radical 3 as our solution. When we solve this, we're just dividing. So the radical 3 is going to come to the numerator, right? Because we have 1 divided by 1 over radical 3. And this flips. So we get 1 times radical 3 over 1. And our solution is just radical 3 for the cotangent of negative 150 degrees. And it's positive because cotangent is always positive in the third quadrant. All right? Thank you.